Okay, so chapter 5, section 4 is using medians and altitudes. So we've talked about the perpendicular bisectors. The perpendicular bisectors come together. They meet at a point of concurrency. That point of concurrency is called the circumcenter. The circumcenter was equidistant from the vertices. Then we did the angle bisectors. The angle bisectors all came together at a point of concurrency. That point of concurrency was called the incenter, and the incenter was equidistant from the sides of the triangle. Now we're going to talk about medians and altitudes. What they are, how you identify them, where they meet up, and what that means where they meet up. So let's talk about a median. So a median in real life is that thing in the middle of the road that kind of divides the left side from the right side. It's like where, like sometimes, it's not just a line, but it can be just a line. But a lot of times you see that like grassy area in between one side of traffic and the other. Like they put trees in it. That's the median. It separates two halves of the road. So a median is a segment whose endpoints are a vertex. So it goes from a vertex. So like up here at C is a vertex. And then connects to the midpoint of the opposite side. So how is this different than a perpendicular bisector?
It doesn't have a right angle.
It doesn't have to be perpendicular. So a median goes from a vertex to the midpoint on the other side. It does not need to be perpendicular. And there are going to be 3 of them there. So think about it. If every single side of a triangle has a midpoint, which it does, then every single vertex can connect to the midpoint on the opposite side. So let's say that, I'm just kind of guessing where these are at. I'm eyeballing it here. 1, 2, 3, 1, 2, 3. Midpoint connecting to the vertex on the opposite side. Those medians meet up at a point of concurrency. That point of concurrency is going to have a name, and we're going to talk about why it's significant. So being able to identify a median is the most important, because by all means, even without the words on there, I would expect that if I gave you this diagram, even without being able to see, zoom it in there, even without being able to see the word median, I would expect you to understand that those are medians coming together just by looking at the picture. Yes, sir?
Wait, I'm confused. Is the median like where it's pointing, or the median is like...
The median is the line, the red line, the blue line, and the green line. Just like we had perpendicular bisectors that were lines, just like we had angle bisectors that were lines, these are medians that are lines.
How are the lines meeting? Like, you said like each side of the triangle has is congruent.
No, not congruent. Each side of this, like this side here, the green ones, that's congruent. So that's the midpoint there. See the green dot? It's a midpoint. A median goes from a midpoint to the vertex on the other side. See the green line? It goes from a midpoint to the vertex the other side. See the red one down at bottom? It goes from the midpoint to the vertex on the other side. Blue one, midpoint, vertex on the other side. So that's how we define a median. Yes, ma'am?
Can you zoom out a little bit?
Yes, but I'm about to move on, so go quick. You're going to have to catch up just because there's so much on here. Just go. We'll come back to it at the end. Okay, so that point where all the medians meet up, that point is called the centroid. So this is that point of concurrency. It's called the centroid. 3 medians meet up. Where they meet up is called the centroid. Now the centroid is actually kind of cool in real life because the centroid is actually the center of gravity, meaning that this is where it would balance perfectly on. Like if you were to put your finger on that point, you could balance this triangle on your finger or on a pencil or on the head of a pin if you wanted to, if you knew exactly where the centroid was. The centroid is always inside the triangle. Always, always, always. It can never be outside of the triangle. I mean, think about it. If the centroid was outside of the triangle, how could you balance the triangle on this point? It wouldn't be able to. The centroid is also called the center of gravity because it is the point where a triangular region will balance. So like if you were to take it and put it on a pencil there, it would be the center of gravity. Now somebody earlier today said, wait, how is this? It's not in the center of the triangle. That's not what center of gravity means. Center of gravity. So if you look at my Apple stylus back here, where I balance it on my finger is going to be, now I'm not incredibly coordinated here. Where I balance it on my finger is its center of gravity, meaning that it is equally dispersed. All of its mass is equally dispersed So what we're looking at here is that's the point where it balances. Now, if you notice, I'm not 50-50.
Why can't I do that?
It takes a little while. So if you if it's not 50-50, it's not like balance so that one half of it is on one side and one half is on the other. Because the Apple Pencil is a little bit heavier on one side than it is on the other, it means that it balances where it's off center. So in these triangles, the centroid will always be that center of gravity there, so that all of the weight of that triangle is equally dispersed around that point there. So it allows you to balance it. That's the center of gravity. You have your own center of gravity too. People who have a really good center of, who have a really good balance, are usually able to identify their center of gravity. Like gymnasts are usually very good knowing where their center of gravity is. And they kind of rotate their body around that point there. It helps them maneuver and land things very easily, is being able to identify their center of gravity. So, here's why we care about the centroid. Not just that you can balance things on it, we can do things mathematically on it. So those medians, first of all, looking at this picture here, forget about everything that it says there. I'll go back to the words in a second. Looking at the picture there, how do I know that that is the centroid?
Because of the lines from the angle to the midpoint.
I need a little more than that. Yes, sir.
Because that is where all the lines meet up.
What lines?
All the midpoints. I'm sorry, the mediums.
Okay, so how do I know these are medians?
Because they're congruent.
Tyler.
From the
Because they're
angles.
all at a vertex and the opposite side is in the middle of both sides.
Good. So it always goes from a midpoint to a vertex. Midpoint to vertex, midpoint to vertex, midpoint to vertex. So a whole bunch of medians here. So what we've got there is the centroid. Now here's why we actually care about the centroid. It's cool that it balances there, but here's the real part that we care about when it comes to math. Those medians intersect at a point. And that point, mathematically speaking, is 2/3 of the distance from each vertex to the midpoint. And here's what that means in plain English. I'm going to look at this line going straight up and down first. I'm going to do it to all of them, but I'm going to attack one at a time. This line has a length. I don't know how long it is. It is a certain amount length. But this part from the centroid to the vertex is always 2/3 of the whole line. Now that whole line is called BF, right? So that part right there represents 2/3 of BF. Well, if that's true, then this one right here must be how much? 1/3. If the whole line is a certain amount, well then 2/3 must be up there, and the remaining 1/3 would be down here. Now, sometimes people go, well, how do I know which one is the 2/3 and which one is the 1/3? Well, first of all, the 2/3 will always look longer, but let's say that you want it a way you're like, well, what if it doesn't, I can't really tell. Well, the 2/3 part will always be touching the vertex. So if you notice this line, I'm doing this green one now. So however long that is, this part right here represents 2/3 of the whole line, and in this case, the whole line is AE. And this part over, I'm going to change color so it stands out. This part right here represents 1/3 of AE. So how does this actually work? How does this actually help us out? I'm going to show you. Bless you.
Wait, so the line with 2/3 is always on the vertex?
It's always touching the vertex. The part that is touching the vertex, that's the 2/3. So let's say that I've got a triangle like this. A, B, C. Here's a vertex. Here's a midpoint. And I have this line going down here. And if I told you that point, I already used C. Let's do point M. I don't know. If I said that point M is the centroid, and I told you that, this will be D. If I told you that BD is 21 units long, then how could we figure out how long BM is or how long MD is?
So I would divide it by 3.
Okay.
And then since I know that VM, the line touching the vertex, is 2/3, I'll multiply that number, the I divided by 3, which would be 7.
Okay.
By 2, and I'll get 14.
Okay, nothing wrong, 100% right with everything you did. Let me tell you exactly what you did and why I wouldn't do it that way, even though it's completely right. I'll tell you why I wouldn't. Because when numbers are simple, it's very easy to do it that way. When numbers get hard, it's not easy. So here's what he said. He said, I would take this line, that line that's right there, and I'll split it into 3 even pieces. So if it's 21, he's going to split it into 3 even pieces. So he's going to divide it by 3, and he's going to say that each piece is 7. And he knows there's 3 pieces. So if this is 2 of those pieces, then that one becomes 14, right? 2 of those 7 pieces become 14, meaning the remaining one is 7. But here's why I would not do it that way, because I'm going to give you numbers that won't divide evenly. And I'm going to give you things that are algebraic expressions like x plus 7. And then how do you split that into thirds? So here's what I'm going to recommend doing. We all know that, hold on, BM, that part that's up there at the top, is, BM is 2/3 of BD. Notice how I just took exactly the words that we said and I turned it into a statement. BM is 2/3 of BD. Now, one of those things that I just wrote there, I know. What is the thing that I know up there? And BD is how much?
21.
21. So BM is 2/3 of 21. If you like, you could sit there and you can do this. You can divide by 3 and then multiply by 2. The same thing that Marcelo did, except for we're going to do it. We're just going to do it in one step here. So,
I thought you just said sometimes they don't give you a number.
right. What I'm saying is that this method will work no matter what I give you.
Wait, what if you got like a variable for 21?
That's what this will work even then. If this were 2/3 times x plus 1, you can distribute that. You've done that before. That becomes 2/3 x plus 2/3. So no matter what, you could do this. Now, does it end up with a variable in there? Sure. In this case, we can do it very easily. 2/3 of 21 is 14. But let's do this. DM, that piece that's on the bottom, DM is not 2/3 of BD. It is what?
1/3.
It is 1/3 of BD. So notice how we just make the equation by saying it. DM is our word for equal, is 1/3 of BD. In which case we can find that remaining piece there. So that's what it does, is it helps us find the length of things, and we're going to do an example in just a moment. Okie doke. So, in this triangle LMN, RL, I'm just going to color code things so we know exactly what we're talking about. RL is this line. That line is 21. And SQ, which is this line here, is 4. Now, before we start getting into equations, you better start talking to me about what's happening in this picture. Because you can't do anything until we talk about what's happening in this picture. There's nothing else that's written there. It's just asking us to find some things. Some people will be like, oh, I'm just going to use this equation. Then you better justify why we can start doing stuff. What do we have going on in the picture?
So you know that it's a medium, or like it's a centroid,
Good. How did you know that this is the centroid?
because you have 3 mediums meeting up at one point.
3 medians meeting all up at that point. Yep, no, it's okay. It's easy to mix up. 3 medians all meeting up at this point, which is the centroid. So now we know some things. Now I'm okay with setting up some equations.
So you know that line, so I did line RL.
Okay, so, well, let's start with, we want to find LS. What do we know about LS? LS is what?
1/3 of line RL.
2/3.
I'm sorry, 2/3 of line RL.
2/3 of RL. So all we did is we took exactly what he said and turned it into an equation. LS is 2/3 of RL. Now, one of those things I know up there. What can I plug in?
You can plug in 21 for RL.
Good. LS is 2/3. Did I just use the same numbers I did on? Oh, goodness gracious me! I'm such an idiot. 2/3 of 21. Well, that should make this easy then.
Wait, then can you, no.
Which is 14.
Which is 14. But that's okay because the other one is not one we did like that. We also need to find NQ. Let's turn NQ into a statement.
And he,
So SQ, SQ is 4.
Okay, but let's get an equation because it's just saying it's 4 is kind of.
Okay. So NQ is, which is two.
Would it be easier if you guys talked about SQ? Like, because you can talk about it the other way too. Like, you know SQ, right? Sometimes it's easier for people to do it the other way.
Like, can't shoot.
SQ is 1/3.
Okay.
NQ.
SQ is 1/3 of NQ. Notice it's got the two pieces he needs in there. It's got NQ and it's got the SQ. So really, this equation will work well too. It's not, there's nothing wrong with it. So in this case, what do we already know?
You know that the 1/3 is 4.
1/3, the SQ is 4, right?
Yeah, the SQ equals 4.
Okay, so 4 is equal to 1/3 of NQ. Algebraically speaking, how do we work this out? How do we figure out what NQ is?
Divide 4. I'm sorry, multiply 4 and 3.
What?
Oh, so to get NQ by itself, we need to multiply.
No,
We need to multiply. Hold on. We need to multiply the right-hand side times 3, right? The 3 will get rid of the 1/3. Yeah.
And then, no, you multiply to both sides.
Right, and we also need to multiply it to the other side.
Okay.
Because to get rid of a 1/3, you got to multiply by 3. We have 1/3 of NQ. To get rid of that, we have to multiply by 3. In which case, NQ is 12.
Wait.
You do it using 2/3. Or is it not?
Well, 2/3 is NS. It never asked us about NS. That's why we didn't do it that way. So NS is that bigger piece. So it asked us about NQ, and NQ is the whole thing. SQ is the smaller piece, so we used the 1/3 part there. I mean, you could probably work something out that way, but it's much longer and would take more steps there. Okay, so let's deal with this one here. If you are getting ahead of me, just know that there is an error in one of the slides, so you're going to run into some problems if you're shooting ahead of me. A sculptor is shaping a triangular piece of iron that will balance on the point of a cone. So what we're talking about is this. Some sculptor is making a cone. Sorry, my podium's wobbling, so
A call.
a cone. They're making a cone. And on that cone, they're just trying to show this. They're going to balance a triangle on that cone.
So we need to find the
No,
The media center?
No.
The media center is in your house where you keep your TV and usually...
Central.
The centroid.
Yeah.
We need the centroid. So the centroid is where what kind of lines come together? The medians. And the medians go from what to what?
The midpoint and the angle.
Good. So the vertices are easy to see, but what is not easy to see are the midpoints. So we're going to need the midpoints of these lines.
So we did the midpoint.
Let's do the midpoint of this first of all. So let's just go x1, y1, x2, y2.
Sorry.
What is our midpoint formula?
X1 plus X2
Over 1.
Y1 plus Y2.
Good. Make sure that you make it positive. Some people lost points in their quiz because they decided to make that equation have a subtraction in it. So we're going to add the x's together. 10 plus 6 divided by 2. And then we're going to add the y's together. 6 plus 7 divided by 2. 16 divided by 2 and 13 divided by 2 gives me the coordinates 8, 6.5. Or 6, 13 halves, whatever you want to do, whatever helps you find it here. So I'm going to go 8 to the right and 6.5 up. So this is my midpoint for that line. I'm going to connect it to the vertex on the other side. There is one of the medians. I don't care which side you move to next. Let's just go to the left because I've already got, I just see it right there. I'm just going to go to the left.
I have a question.
Yes, sir.
So if the line, let's say that it's on the actual line of the graph, for example, like a right angle, well, no, because that, like, it could be on. But if it's actually on the line, can you just count the little squares and then go after that?
Yes, but let's not talk about that one yet. You're going to see that in a minute. Okay, so now we're going to we'll call this one x2, y2. Let's find the midpoint of the blue line. So we've got 6 plus 8. Add the x's together, divide by 2. Add the y's together and divide by 2. We get 2 plus 6 divided by 2. In which case we get 14 divided by 2 and 8 divided by 2, which becomes 7, 4. So at 7, 4, we have a point right here. And it connects to the vertex on the other side. Now, we are looking for the place where all 3 lines converge, all 3 of them. Have I drawn 3 lines? No, but I already know where they're going to converge. How do I already know where they're going to converge? It's not a guess. Because 2 of them have converged. So if
we only need to find 2?
well, check it out. If you know where 2 of them converge, look if I drew any other line. Let's say that I put a line here. I put it right there. Did all 3 of them converge anywhere? No. If I drew a line anywhere, here, did all 3 of them converge anywhere?
Well, what happens if you did the addition wrong?
Well,
And you'll see it when you do.
Well, then you just
well, then your math is wrong. I mean, that could happen even if we did 3 of them. So what we know from this is that if we were to find that last spot, I'll prove it to you, but just so you know, this is definitely the centroid. I already know that all 3 things are going to meet up there. So check it out. Give me a second, you put your hand up. If I already know that 3 of us are going to meet somewhere, and 2 of us are already at that location, then guess what? I know where the 3rd person is going to meet us. But let me just show you real quick that we're going to do this last line here, just to show you that it's going to end up in the same place as well. So I am going to add the x's together. We got 10 plus 8 divided by 2. And we get 7 plus 2 divided by 2. I'm doing the midpoint of the green lines. 18 divided by 2. 9 divided by 2. We get 9, 4.5. So let me go to 9, 4.5. 9, 4.5 is right here. And when I connect that across there, what do you know? Look right where it went through.
Mr. Hart, so for the black line, will the point, like the middle one, always be on that line?
No. Will it always be on what line? The black line?
Yeah.
Yeah, well, yes, because it's that point there, it has to be on all 3 of the lines. It's on all 3 of the lines. It has to be, or else it's not the centroid. Yes, sir.
Wait, wouldn't you be able to tell whether they're you know where it is? Because every median has to be connected with a vertex, right?
Yes.
So wouldn't you know that it has to be there?
How do you know where it is? Not with one line, because it could have been here, it could have been here, it could have been here, it could have been here.
But wouldn't you know that
But yeah.
I didn't know until 2 of the lines crossed. As soon as 2 of the lines crossed.
After 2 of the lines
Well, that's what I said. We did. We said it. We already knew that was the centroid when we had 2 lines crossed. The reason I did the 3rd line was just to prove that it actually was.
Oh, okay.
So we didn't need to do the 3rd line. The 2nd line was enough because 2 of the lines had crossed there, so we knew that had to be the centroid. As long as our math was good, that had to be the centroid. So it says, what are the coordinates where it'll balance? Well, it's the coordinates of that centroid, which looks like it's going to be at 8, 5 based on this.
So the 3rd one is just to check.
Yeah, sure. If it didn't, then we would probably say, if the 3rd line didn't go through there, I would be like, wait, something's off. One of my lines is off. Okay, so that's medians. Medians are made from midpoints and vertices. They come together at a point of concurrency. That point of concurrency is called the centroid. The centroid is 2/3 of the way along the median to the vertex. So we've got all that information. And then we get to the altitudes. And I'm going real slow on this slide because for some reason, this slide in particular drives people crazy. So I'm going to go real slow. If you're not paying attention, you're going to want to, because for some reason, this is where people go like, I have no idea what you're talking about. An altitude. Altitude is a perpendicular segment. It goes from a vertex to the line containing the opposite side. Every triangle has 3 altitudes. An altitude can be inside, outside, or on the triangle. Don't worry, I'm going to break it down into English. So, altitudes. If you think about an airplane, we talk about the altitude of an airplane, right? How high up is it? So we say like maybe it's 30,000 feet in the sky, and we measure it from that point directly down to the ground, perpendicular with the ground, making a 90-degree angle. It wouldn't make sense if an airplane was flying over Fort Lauderdale and we measured the distance from Iowa to that airplane to say how high in the air it was. That wouldn't make any sense. We need the altitude, which is directly up from the ground.
It would be the same height.
Hold on one second. It would not. If you measure from Iowa to the airplane versus here and straight up. Like think about it.
The same height. It would be the same.
It would still have the same height, but you would not get the same measurement. Is that?
But yeah, we're not the same height though.
No matter. Okay, well, we're debating two things. The aircraft's height is its height. It has a height. Like my height is 5'9.5". That's my height.
Everywhere.
And I go no matter where I am. But how you measure it would be. Hopefully you measure that from the ground straight up, not from like North Dakota to the top of my head. That would not represent the height. So my height never changes. But how you measure height is very important. It has to go from the ground straight up. So here's why altitude is difficult. Because altitude goes from a vertex to a line on the opposite side that contains the other side. So check this out. This is where it gets a little wordy. I'm going to look at the vertex right here. Now there's other ones. I'm only starting with one line so I don't freak anybody out. The side of the triangle that is opposite from there is right here. Are we all okay with that? All I'm doing is looking at that vertex and the side that's opposite.
No, I don't get that.
Wait, what do you mean it's opposite?
It's not on the same, I'm not touching that side. It's the one that is opposite from there, like this. It's opposite.
Wait.
I don't get that.
Okay.
Oh wait. So it's.
Okay, wait.
So
Hold
it's
on,
like
hold on, hold on,
not
hold on,
touching.
hold on, hold on. Here's a triangle. This vertex is opposite from that side.
Yeah.
This vertex is opposite from that side.
Yeah.
This vertex is opposite from that side.
Because they're not
I'll-
touching.
Yeah, I'm doing the same thing here. I'm only looking at the black triangle. Forget about everything else, just the black triangle there. Same thing. Okay. The triangle. Okay, well give me a minute to address all the lines. I'll get there. You guys are freaking out before we even get to the hard part. We haven't even done the hard part yet.
Oh my god.
Okay. Now, I need to make a line that is perpendicular. It's got to go from the blue dot up here. It's got to go from the vertex to the other side and make a perpendicular line. Perpendicular meaning what?
90 degrees.
Okay. Now stick with me for just a moment here. I'm going to rotate this so that, like, see how that blue line is on the bottom now? So that it's very easy to see 90 degrees. Watch what happens when I connect the line here.
Where?
Hold on.
Everywhere.
Is that 90 degrees?
Yes.
Definitely not. It doesn't even, it's an obtuse angle. It's definitely not. Is this 90 degrees?
Awesome.
No, that's not going to be 90 degrees. This isn't going to be 90 degrees. That's not going to be 90 degrees. That's not going to be 90 degrees. If I want to make 90 degrees, none of those lines in there are going to work. But if I want to make a line from that dot that is going over to the opposite side, I might need to extend this line just a little bit so that I can make a 90-degree angle. So now I can make a 90-degree angle if I go right straight to the ground. That blue highlight area is the ground. The altitude is actually outside of the triangle. If you will, imagine that this is some weird triangle-shaped building that slants to the upper left, okay, if you will. If you stood on that top and dropped something from it, it would fall straight to the ground. It wouldn't fall inside the building at a diagonal. It would go straight to the ground. So one of the altitudes is outside of the triangle. It is that blue line there. Why? Because I had to connect it to the opposite side, and to do so, it had to go outside of the triangle. Now this is not part of the triangle. It's an invisible line that I had to extend to show where the altitude would be. I know that's confusing, but let me do it 2 more times, and maybe you'll get more comfortable with it, okay? Yes, ma'am.
How do you know if it's a straight line though? Because like sometimes if you write a line, it'll be a little off.
Well, this one they're showing here. Now trust me, this is easy compared to how we construct them. But in the picture, it's a straight line. If they're showing you a line that looks straight, you can assume it's straight. You don't need to assume that it's not like bending.
For like the future test of quiz, are we gonna have to construct the line?
We're not to that level yet.
So like we don't have to know after this lesson.
Yes, you will, but you're not there yet. Wait, pause. Everybody's coming up with these what ifs. We're not past the first part, and you guys are already talking about the 6th part. So give me a second. First part. That was one of the altitudes. I'm going to do another altitude. To do another altitude, I'm going to rotate it a bit. And I'm going to start at point S and make an altitude. Because remember, I have to go from a vertex and go toward the opposite side. I just need to raise it up a little bit. Towards the opposite side
Wait, from what?
of the triangle. We're always talking about the triangle.
Which triangle? There's like some.
Okay, so from the yellow dot, I'm only focusing on the black triangle here. I need to go to the opposite side. I also need to make a perpendicular line. That will not happen inside this triangle. Look, that's not going to be perpendicular. That's not going to be 90 degrees. That's not going to be 90 degrees. That's not going to be 90 degrees. It won't happen for this one either unless I am willing to go outside of the triangle and extend this line a little bit. This is another altitude that is outside of the triangle. Okay, I'm only looking at the yellow. Forget about the blue. We did the blue. We made a blue altitude. Now we're making a yellow altitude. It is this piece right here. We have 2 of the 3 altitudes. To get the third altitude, I'm going to need to go to the vertex that I haven't used yet. I've used 2. There's one more. I'm going to put it on top just so I can look at it. Where that blue and yellow line meet up, that is my third vertex. Right there. And I'm going to go to the opposite side and make a perpendicular line.
Wait, I lost where the triangle is. The black triangle.
So look at yours, because you have the same picture, and yours probably doesn't have all the same lines on it.
Wait, so one thing that's really confusing me,
Okay.
you might have already said this, but if we're only focusing on the black triangle, what are the red lines?
Those are the altitudes. That's what we're drawing. We're drawing the altitudes. The red lines are the altitudes. But I haven't gotten to that point yet. Like, so we're only, like, again, only focus on the black triangle here. We'll get to what the red lines are. So just the black, all I care about, all I need you guys to focus on here, like I said in the beginning, just focus on this black triangle for just a moment. That's the triangle we're working with. Everything else represents the altitudes. And I'll show you that, but we're not done. We haven't drawn them yet. So, the green line, I now have a third altitude, which is right here. But notice that the green line that I drew right here, the yellow line that I drew over here, and the blue line I drew over here are not intersecting each other. Do we agree? Until we keep them going and find out where they would intersect. Keep them going. Just keep drawing them until they intersect. They do intersect at a point that is on the outside of the triangle.
What is that called?
That's our next slide.
Oh.
This is a point of concurrency of the altitudes, and we're going to talk about what that means on the next slide. So, what you're looking at there, I had to rotate this all sorts of crazy ways to talk about them. So, I'm going to give you a quick little summary on another picture here. I'm going to make this a little bit easier. I'm just going to do another triangle. Here's another triangle. I'm going to make the easiest altitude first. I'm going to start right there at the top here. I'm going to go from a vertex and go and make a 90-degree angle to the other side. Are we okay with that?
Yes.
That is an altitude. Anybody not okay with that? Because I'm going a little bit slower here.
Very altitude, yes.
Okay, I'm going to pick another vertex and do the same thing. I'm just putting it on top, that's all. This vertex up here has to make it, this one here, has to make it over to this side. But no matter how I draw it to that side, it's not going to be 90 degree and a 90-degree angle unless I'm willing to extend that line. And then I can make an altitude. Are we okay with that? All right. So we have 2 altitudes. The first one is that black line down the middle. The second one is the red one. I'm going to do the third one from the vertex that I have not used yet. I need to go from this vertex to the opposite side But if I were to connect those lines, it would not make an angle that is perpendicular. To be able to do that, I would have to say, okay, well, I could do it if I extended this line and then went straight down to that line at a 90-degree angle. Are we okay that there are 3 altitudes there now? I'm just going to zoom out. Those are my 3 altitudes.
I feel like the reason it didn't make sense on the other one is because like it was hard to tell.
I could tell. It's the red lines that were throwing everyone off.
Yeah.
Are we a little bit better with this?
Yeah,
Okay, but here's the problem with my altitudes. What's the problem with my altitudes?
they're not meeting at a point.
They're not meeting at a point. So I'm going to keep them going. I'm just going to keep my lines going. Sorry, that curved off there at the end. I'm just trying to fix that. There's one of them. Till they meet up at a point. And this point is a point of concurrency for the altitudes. And we're going to talk about what that is in just a minute. Yes, ma'am. Did you have a question?
How did you do the black one?
With the black one we started here. I went from the vertex on top straight to the other side. Yes, sir.
So for the altitudes, how do you know, like, how to draw the line to make it perpendicular?
Well, we're not there yet. That was the question that was at the beginning. I said we're not there yet.
Okay.
I'm just showing you by definition, this is what the altitude is. Yes. So, that point where they meet up is called the orthocenter. You don't need to know anything else about the orthocenter other than it is called the orthocenter. That's it. For right now, all you need to worry about, you don't need to know any formulas, you don't need to know any math of it. The altitudes meet up at something called the orthocenter. That point of concurrency is the orthocenter. So that orthocenter can be inside the triangle, it can be outside the triangle, it can be on the triangle. Now, here's where we get to the actual numbers of it. This is the part where people go, well, how do I do it myself? How do I find the orthocenter myself? Here it comes. And you need to make a change to this because there is a problem on here. If you would please change z, the coordinates of z. There's an issue on here that I caught this morning, that z, its coordinates need to be 7, 2. If you don't make that change, there's no way this will work out. 7, 2. So change it to 7, 2. It says find the orthocenter of triangle XYZ with the vertices x is at 3, -2. Y is at 3, 6. And z is at 7, 2. All right. Our triangle looks like this. We have a triangle there. What we're interested in is the orthocenter, where the altitudes meet up. Now, an altitude goes from a vertex and goes to the opposite side. So there's a really easy one to do on here, right here. Look at z. If I want to make something that is perpendicular to that red line there, to that red line that is going vertical, what is a line that is perpendicular to a vertical line?
Horizontal.
A horizontal line is perpendicular. A horizontal line and a vertical line will make a 90-degree angle. So if I want to go from z to that vertical line, I just need to connect it right there because I already know those are perpendicular. One is vertical, one's horizontal. That was nice and easy. That is one of the altitudes right there. Here is an altitude right there going from z to the other side. Now the ones that are harder are the ones that are not going up and down. So let's try to do from that blue point up there to the opposite side. Now, if we are going to make a line that is perpendicular to this blue line, then what needs to be true about the line that we're going to draw? If it's going to be perpendicular to this line.
It needs to have 90 degrees.
Huh?
It needs to be 90 degrees.
Yes, but how do we make a line that is perpendicular? Like, what do we know about, how would we find out if something is perpendicular to this line right there?
You need to extend the line.
But we can't just draw it. We're gonna.
If you were to turn the triangle like straight, the line going through it would have to be vertical.
If two lines are perpendicular to each other, what is true about their slopes?
Oh, they meet at one point.
No. Yes, ma'am.
Their slopes are their slopes have the zero in each of them, like the right now.
No. Somebody else. What? Opposite reciprocals. So, if I could find out the slope of this blue line there, then I know that the line that I need has the opposite reciprocal slope. So let's find the slope of the blue line. I'm going to do this quickly now. I need you to stick with me because this is taking a little longer than I expected, and I was hoping to get your quizzes back to you today. So I got to move quickly. Slope is y2 minus y1 over x2 minus x1. I need you to write quickly because I don't have time to explain slope right now. So we've got negative 2 minus 2 over 3 minus 7, which becomes negative 4 over negative 4, which is the same thing as positive 1. A negative over a negative is a positive. The slope of that blue line is 1. So what is the perpendicular slope then? Somebody just tell me.
Negative 1 over 1.
Negative 1 or negative 1 over 1. So check it out. My line has to go from this vertex up here at y and use a slope of negative 1 or down 1, right 1. Down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Oh, it turns out that these two lines actually are perpendicular to each other right there. How did I know that? Because these two lines have opposite reciprocal slopes. I just checked them. So, notice the red line met up here. One of the altitudes went here. The other line went here. Do I need to do a third line to figure out where they're going to meet up?
No.
No, they're going to meet up right here at 7, 2, because two of them are already meeting there. If they're all going to meet at one spot, it has to be there. They're not going to like wrap around the corner and meet up there again. So in this case, 7, 2. I'm going to leave that up there while I hand out your quizzes.